Hello my dear students. Today we are going to learn photodiode. So last class we stopped with reverse biasing. We have done PN junction diode, forward biasing, reverse biasing. Now we can discuss about photodiode. Okay. So you can make heading as photodiode. So initially, when you study this topic, which is an important topic, photodiode, by the name you remember photon. Photons means what? Light, right? Light energy. Here in photodiode, light energy is converted into electrical energy. That is the first point you should remember when you hear the name photodiode. That is photo or photons means light, right? So here actually happening, light energy is converting to what? Electrical energy. Okay, this is happening and how we can explain that. And the photodiode is connected in reverse biasing mode. You remember reverse biasing mode. It is connected in reverse bias. Okay, that is how. You remember PN junction diode, right? This figure we have already studied. So you can refer those videos. P type, N type. In P type, majority charge carriers are holes, right? Majority charge carriers are holes. And in N type, majority charge carriers are electrons. And there will be minority here electrons and here minority holes will be there. And this is what? This is the depletion layer. Here comes plus charge, here negative charge, plus to minus, there will be an electric field will be there. Now in reverse biasing, how we will connect? P is connected to negative terminal and N is connected to positive terminal. Okay, this much we know about reverse biasing. So this is a photodiode and we have placed a window here. Here let the light energy or light strikes in the photodiode. So there is a window. Through that window, where the light is coming? The light is coming to the depletion layer. So the light is striking on the photodiode. Light has what? Light has energy. Energy of light. HF, you remember, right? This one. H is a Planck's constant. F is a frequency. One photon. Energy. Light comes with energy. E is the energy. So when it strikes this depletion layer, the light comes inside the depletion layer. And now you have to remember, this point is important. What is inside in the depletion layer? Is anything there? Yes. There are neutral atoms are there, right? Inside the depletion layer we have what? Neutral atoms are present there. Neutral atoms. There are no charge carriers. You can say it is an unused section. But there contains what? Neutral atoms. That means if you are using a silica diode, silica has valence electrons 4, right? Valence electrons 4, which is a neutral atom. And once this light energy is come and strikes on the depletion layer, which has this neutral atom, what happened? The electron get excited and comes out. And this electron now is what? Free. And at the position of electron, we have a hole now. Clear this point? This point is a main part of this photodiode. What happens? When the light energy strikes on this neutral atom, electron get excited and becomes free and there generate a hole. So these electrons and holes are charge carriers. Since there exists an electric field, they will go to here, yeah. In this we have now an electron hole and an electron, right? So they will, due to this electric field, the hole is positive, it is attracted towards negative, right? This is negative. So hole will go to this side An electron, it is attracted towards plus. So it will go to N type. So holes will increase, right? Since the light energy is coming continuously, more neutral atoms get excited and more charge carriers will develop. And this holes and electrons thus generated, holes will come to P type and electrons will go to N type. So what happened? That is the next important point you have to remember. Number of charge carriers increases. Correct? That you have to note. Charge carriers increases. There is a rise in charge carriers. Charge carriers increases. And what happens when charge carriers increases? Current, there will be high jump in current. Since you remember in reverse biasing, in normal reverse biasing, there will be which current is going due to minority charge carriers. Microampere current is there, right? Microampere current is there, which is a stable current will be there. When the light is falling, that stable current suddenly jumps and the current increases. So if we plot the graph of this current, it will be like this. You can up and downs you can see. Okay. That is, initially it was microampere. Assume it has 10 microampere current initially before the light is falling on the photodiode. It was in the reverse biasing mode, a constant current which is 10 microampere. Once the light falls, the charge carriers increases. Then what happens? Suddenly it reaches to 50 microampere. That is sudden jump. So 50, 10, 50, 10 like that it will be. How it will be like that? That is, the main application of this photodiode is, it is used as a counter. It is used as a counter. That is, you know, when you enter a mall, the door suddenly opens as you cross. At the same time, when you pass it, it will close. So there this application is actually following. That is, there will be an invisible light. Once we cross the light, the light is cutting. That means it comes to 10 microampere. When we cross and pass, when we get inside, again that light is there. So it will jump 50. So as the number of person, it is counting 1, 2, 3. That is how many times we are cutting the light. It is coming to that constant reverse biasing voltage, right? So like that we can give a count. Same way money counting machine, same procedure. So the money is counting when it cut the light, 1. That is going down. So again cutting light, 2. Like that we are getting count. Clear? So this is actually the working of photodiode. It is simple. These are the key points you should remember. In a photodiode, which is also a PN junction diode, where light is passing through it, the light is going through the depletion layer. The depletion layer has neutral atoms. When we strike when the light is strike on the electron, it will get excited and get free. So the generated holes, the electrons and holes will get attracted to its own opposite charges, P and N. So the number of charge carriers in both P type and N type increases, which will happen a sudden jump in the current from the constant microampere current of reverse biasing. So it is used mainly as a counter. So when the light cut, it will make as a count. So hope it is clear now what is photodiode. It's working with figure. You study the key points and just like a story you remember. Okay. So the next class we can continue. Till then, bye.